Okay guys, this is a problem, a video addressing the block problem from Mastering Chemistry, where one substance vaporizes off of another. And this is not your exact problem. I am not here to do your homework for you, but I'll be happy to help you. Anyway, it's worded something like this. So a puddle of ethanol, C2H6O, weighing 1.00 grams on a block of copper weighing 40 grams evaporates. If the initial temperature of the block is 20 degrees Celsius, what is the final temperature of the block? Okay, so the way that you approach this is you ask yourself, what do I know? What does this actually tell me? So if we start with the alcohol, we know that we have this puddle on the block, and if pictures help you, draw them. But we know that we have our mass equals 1 gram. Okay, so after we do that, we can add up the weight of the ethanol using our periodic table. You guys passed Chem 1, so you should know how to do this, or it will be given to you on the test. But either way, you need to know how to do this, and I got 46.07 grams per mole. I rounded up. So, then you'll either be given or we'll have a chart where you can look this up, which will be the enthalpy of vaporization for ethanol, which I found to be 38.6 kilojoules per mole. We don't memorize these, we look them up in charts too, so don't stress yourself out. So we know an enthalpy of vaporization, we know a formula weight, and we know a mass. And the link between these is we know grams can go to moles, which can then go to kilojoules because of the heat of vaporization. And that's what we know about the alcohol. So that's Q equals 1 gram. And I'm putting down the 1 gram, but I'm actually going to change it to the number of grams times the, okay, and that's over some number of grams. And this is your formula weight, so it's 1 mole over the formula weight, so it's actually the inverse of the formula weight. And then we're multiplying that by the enthalpy of vaporization, okay, which is some number of kilojoules per mole. So our moles will cancel, and our grams will cancel, and then we're just in kilojoules. And the cool thing about the number of kilojoules that we got is that energy had to come from somewhere. So the energy supplied to this puddle here came from this block of copper, which is pretty sweet. So we know from this word problem that we have 40 grams of copper. And we can look up the formula weight in the periodic table to be 63.55 grams per mole. I was in a hurry when I did this, so that might be off. But anyway, it really doesn't matter what the formula weight is because you can just plug and chug once you have all this. And your initial temperature of the copper block from the word problem is 20 degrees Celsius. And the only thing we don't know now is the final temperature, because if we have this formula, the heat from the copper is equal to the mass of the copper times the heat capacity of the copper times the delta T. And you'll be given any heat capacity, or you can look it up in your book for Mastering Chemistry. And I found copper's heat capacity to be 0.385 joules per gram degree Celsius. Okay, so because the heat from the alcohol was actually supplied by the copper block, we are not worrying about the fact that of sign here yet, if because it's technically the negative of the alcohol, but unless Mastering Chemistry stresses you out about it, I don't think Dr. Yang's going to dwell on it, so we're going to move on. So what we would do here is we're going to plug in the answer of the heat from before to this formula, and we would plug in the 40 grams times the heat capacity for the copper times the temperature final minus the temperature initial. But we know the initial temperature to be 20 degrees Celsius. So all you guys are doing then is just solving for temperature final. And you guys can do basic algebra at this point, so you can do that yourself, but that should give you enough information to solve that one.